Hello and welcome to Introductory Routing. This production will explain the design of the Internet and how this design lends itself to accurate packet delivery across the many networks that make up the Internet. This video will also introduce you to different ways that routing protocols are classified and the role they play in routing across the Internet. It is important that you understand the information presented in this video because as a networker, you will be responsible for routing protocol implementation. This presentation is an introduction to which types of protocols you implement in different parts of an internetwork. The Internet is the world's largest collection of networks. These networks are interconnected and allow worldwide communication through email, the web, and other services. However, in order for this communication to take place, routers across the world must first be able to communicate with each other about the networks they know. It is only after this communication among routers that packets can be forwarded to their destinations. In order to better understand packet forwarding, we must first understand the structure of the Internet. The Internet has grown to an extremely large size, so large that it can no longer be viewed as a single entity. Network engineers now view the Internet as a collection of groups of networks. These groups are called autonomous systems, and each group is under a common administrative authority. Examples of autonomous systems include Internet service providers and large global businesses. Exterior Gateway Protocols, or EGPs, are routing protocols that are designed to exchange routing information between different autonomous systems. Therefore, when a packet needs to travel through different autonomous systems, EGPs facilitate this communication. The most common EGP is Border Gateway Protocol, or BGP. Although routing packets across autonomous systems is important, before being routed to another autonomous system, packets must first be delivered to a router at the edge of their own autonomous system. These routers are called border gateways or boundary routers. Border gateways utilize both exterior and interior gateway protocols to facilitate communication. Routing protocols that are used within an autonomous system or within an organization are called Interior Gateway Protocols, or IGPs. IGPs allow routers to exchange information to find the best path to destinations within the autonomous system or organizations. Examples of IGPs include RIP, RIP version 2, EIGRP, and OSPF. Now, let's look at an example that brings these concepts to life. In this example, the process of packet forwarding is shown. The source host at IP address 172.23.16.8 is sending information to the destination host at IP address 192.168.32.1. In step number 1, the source, which is in Autonomous System 200, sends a packet to the destination in Autonomous System 400. Because the destination is on a different network, the source sends the packet to its default gateway router. Step 2 represents the process of interior gateway routing protocols providing a path through the autonomous system toward the border gateway router. One protocol that could be used to route traffic within Autonomous System 200 is EIGRP, Cisco's proprietary interior gateway protocol. Recall that interior routing protocols such as EIGRP allow the routers in AS200 to communicate with each other concerning the best path toward the destination host. In this case, the routers have determined to send the packet to the gateway router in step 3. The border gateway router is necessary because the traffic must flow out of AS200 into AS400 as represented in step 4. The border gateway router has a list of its neighbor border routers. This list is used to find a gateway that will facilitate delivery to AS400. In step 5, the border gateway router for AS400 delivers the packet to other routers that are using interior gateway protocols within AS400. The packet is delivered to the destination network and ultimately to the destination host. We hope this presentation has enabled you to gain a greater understanding of the structure of the Internet and how routers function depending on their placement within the Internet. As you continue your studies, you will learn and practice configuration skills that will allow you to become an architect of the Internet.